Hi, welcome to the section 7.5 notes on the side splitter theorem. So you can see here the side splitter theorem says if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. So you can see that these two lines are parallel to each other. So RS is parallel to one side of the triangle XY, and it basically just splits these pieces up, pieces of the triangle up into proportional parts. So you can see what it says over here to the right, that XR, which is this little piece, over RQ, this little piece, is equal to YS, this little piece, over SQ, this little piece. Okay, so again, it just splits those pieces up into proportional parts. You can still do a problem like this with the way we've learned it in the previous sections, where you go like left side of the little triangle over left side of the big triangle is equal to right side of the little triangle over right side of the big triangle. You can still do that. That is fine. This is just kind of a shortcut. But the thing is, you just have to make sure you only use the side splitter theorem when you're allowed to use it. You have to make sure these parallel lines are splitting these pieces up into proportional parts. The side splitter theorem cannot be used if we're dealing with, say, RS or XY. Because the parallel lines are not splitting those sides of the triangle up. So if we wanted to set up a proportion with RS and XY, we would then have to equal that to like the left side of the little triangle over left side of the big triangle, or right side of the little triangle over right side of the big triangle. So just make sure you're staying consistent and only using this shortcut side splitter theorem when possible. All right, on example 1 and 2, you can see here that these would be times we could use the side splitter theorem. Again, there's different ways to set up a proportion like we've been talking about. You just need to stay consistent with however you choose to do that. So in this particular case, I can say 12 over x plus 1, because again, these two lines are parallel, splitting these pieces up into proportional parts. So I can say 12 over x plus 1 is equal to, and then on the right side, I can say 9 over x. Okay, and so then once I cross multiply, I can say 9 in parentheses x plus 1 is equal to what I multiply in the other diagonal, which is 12x. I think it's very helpful to write the x plus 1 in parentheses, because I think seeing those parentheses are going to help when I distribute that 9. It'll help remind me to distribute that 9. So I think that's important. Okay, so in this case, I've got 9x plus 9 is equal to 12x. If I go and subtract 9x from both sides, I get 9 is equal to 3x. If I divide by 3 on both sides, I get x is equal to 3. And that's it for that problem. If we look at the one, number 2, again, these parallel lines split these pieces up into proportional parts. Okay, so I can set up a proportion there as well. So I can say a over a plus 4 is equal to 12 over 18. When I cross multiply there, 12 parentheses a plus 4 is equal to 18a. When I distribute that 12, I get 12a plus 48 is equal to 18a. If I go and subtract 12 from both sides, I get 48 is equal to 6a. And then I can divide and get a is equal to 8. All right. From there, I've got the side splitter theorem corollary. So it says if 3 parallel lines intersect 2 transversals, then the segments intercepted on the transversals are proportional. So in this case, it's like the side splitter theorem that we just talked about. It looks a little different because we're not actually dealing with a triangle, but these 3 parallel lines split these pieces up into proportional parts. Okay, and that's what it's saying right here. AB over BC is equal to WX over XY. So not too hard to deal with there. And so if I look at this particular problem, I can say 4 over X equals 6 over 5. Then when I cross multiply, I get 6X is equal to 20. And when I divide by 6 on each side, I get X is equal to 20 over 6, which then I can reduce down to 10 over 3. And there we go. You can leave that as 10/3. If you want to write that as 3 1/3, that's fine. If you want to write 3.3 repeating, that's fine. If the directions don't specify, any of those ways would be fine. All right, if you look at example 4, we can see this picture's a little dark, but you can see that these lines are parallel. So again, if you have 3 or more parallel lines, it splits these pieces up into proportional parts. This particular question is asking for the length of side A, which we'll call that X. And again, based on the numbers that we are dealing with, I can set up a proportion with these two and with these two. Okay, so if I set up a proportion, again, staying consistent, I can say X over 8 is equal to 9 over 7.2. If I cross multiply, I get 7.2x is equal to 72. If I divide by 7.2 on each side, then I get 10. All right, moving right along. So on number 5, it says what's the value for x. So here's where we have some options. Okay, we need to stay consistent. Whatever we do to one side, we have to do to the other side. We can see these lines are parallel. It's kind of hard to see that. The marking's kind of small, but those are parallel. And so we need to stay consistent. So there's 2 different ways I can think of here to set up a proportion. If you want to do the pieces like we've just been doing, then I can say 24 over 6. That's fine. Okay, but then when I come to the right side, the x corresponds with the 24, but then down here I don't have anything. So based on what is given, I have to decide what to put there. Well, if I can see that this whole length is 16, and this piece is x, I therefore know that where I just circled here, I could write 16 minus x. Okay, so my right side of the proportion, I can say 24 over 6 equals x over 16 minus x. Okay, and so now when I cross multiply, then I've got 24 parentheses 16 minus x is equal to 6x. All right, from there I can distribute the 24. And when I do that, I've got 24 times 16 is 384 minus 24x is equal to 6x. If I go and add 24x to both sides, I get 30x. And when I divide by 30 on each side, I get x equals 12.8. So that's one method that I could solve this, but let me show you another option. Another option is, say I saw that x and I just wanted to start with the x, and I see that 16 and I want to start with the 16. I could say x over 16. That's fine if I start with that. But if that's the lead I follow on one side, I have to follow that lead on the other side as well. So if I see if I can follow that same pattern, if I did x over, which is kind of the top piece, over 16, the whole piece on the right side, if I follow that same pattern on the left, I would say 24, which is the top piece, over the whole left side, which think about what that is, and that would be 30. So I could cross multiply 30x equals 24 times 16, which is 384. I divide by 30 on each side, and then I get my 12.8. So again, I kind of got the answer a little bit quicker, but again, it's just a different way to set it up. All right, look at number 6. It's a very similar problem. If you want to try this one on your own, one of the two methods that I just showed you at number 5, that's fine. You can pause the video and then join back in a minute. I'm going to go ahead and show you how you can set up both ways. If I do the first way I mentioned earlier, I would say 9 over 4 equals, now I don't know what this top piece is, but if I look at my picture, I know that I can label it 11 minus x over the bottom piece, which is x. Okay, or your other option for setting it up is, say I want to start on the right side and I want to start with the x. I could say x, little piece on the bottom, over 11, the whole piece on the right side. And that's equal to, I need to follow the same pattern on the left side. So on the left side, the 4 is what corresponds with the x. And then the whole left side is 9 plus 4, which is 13. Okay, so again, I can solve either one. I'm going to get the same answer either way. I'm just going to solve the one on the right because I think I'll get to the answer quicker, but either one is fine. And either way, I should end up with 44 over 13. You can leave your answer like that, or you can go and divide and get 3.4. All right. One more. You can do it. Okay, so if we look at this one, I still see a triangle. I still see two parallel lines. I know those parallel lines are splitting those pieces up into proportional parts. They want me to complete the proportion and then cross multiply and solve. So I can see they started off with saying x minus 1 over 4x plus 1. And I know that has to be equal to, follow that same pattern, 2 over x plus 4. Okay, from there, I can cross multiply. So I've got x minus 1 and then times x plus 4 is equal to 2 times 4x plus 1. Okay, so again, I think it's helpful to put parentheses. Anytime you have more than one term, put parentheses around it so that you remember what to do from there. And in this case, if I see two binomials, I need to FOIL, is the way most people learned it, where I'm going to multiply the first two terms, then the outside terms, and then the inside, and then the last. On the right side, I need to distribute the 2. So if I get all that taken care of, then x times x is x squared. X times 4 is 4x. Negative 1 times x is negative 1x. And negative 1 times 4 is negative 4. On the right side, I get 8x plus 2. If I go and combine my like terms together here, I get x squared plus 3x minus 4 is equal to 8x plus 2. Okay, from there, if I go ahead and subtract 8x from both sides, then I'm going to show what I'm doing here. I'm subtracting 8x from both sides. I'm going to subtract 2 from both sides. And that is going to give me x squared minus 5x minus 6 is equal to 0. Okay. From there, I can factor and solve. So there, just like we've been doing in this chapter, we've been getting that algebra practice. We're looking for two numbers that multiply together to give me negative 6 and add together to give me negative 5. So first of all, I need to put x and x in my first two spots here because x times x is x squared. Again, I'm looking for two numbers that multiply together to give me negative 6. So that would be negative 3 and positive 2. And I want to double check to see if this fits both scenarios. Negative 3 times 2 is negative 6. Negative 3 plus 2 does not give me negative 5. So I realized there that that's a problem. My first thought didn't work. So I'm going to get rid of these numbers and then try to think of another option that works, which I'm thinking of. So I realized if I use 3 and 2, there's no way to get a -6 and add together to get -5. So I want to try and think of other factors of 6. And so I thought of 6 and 1. So in this case, I'm going to try these two numbers. -6 times 1 is -6, and -6 plus 1 is -5, so that works. So that tells me that these are my two factors. My two things that multiply together. And once I have factor, but now I need to actually solve to get my solutions. So I'm going to set this equal to 0, x minus 6 equals 0. And I'm going to set that equal to 0, x plus 1 equals 0. And I can solve, add 6 to both sides. I get x equals 6, subtract 1 from each side, and I get x equals -1. And so these are my two solutions to this algebra problem, but in a geometry problem, I need to always make sure that both of those solutions actually work in this scenario. So if I take my 6 and plug it back in the picture, that any of those numbers would make sense. They're all positive numbers. But if I take -1 and plug it back in the picture, I would actually get, if I plug it in 4x plus 1, I would get -4 plus 1, which is -3. Well, that doesn't make sense for a side of a triangle, a piece of that to be -3. So that is what tells me that I should cross off the solution that doesn't actually work with this particular geometry problem. So I know that x is equal to 6 is my actual solution to this problem. Okay, thanks for joining in, and let me know if you have any questions or if you need any help.